We're going to talk about measurements of angles. Angles measure how far something has rotated from a particular fixed point. In this video, we'll be talking about measurements of angles in terms of both degrees, which you might be familiar with, and radians, which you might not be familiar with. We're also going to talk about coterminal angles. Arc length and angular speed will show up in the following video. Let's go ahead and get started. We've got a couple of examples here of circles with some rotations noted in radians. Radians is a really nice way to measure angles when it comes to calculus and some higher level geometry, because 1 radian is equal to the arc length. So we've got that denoted here. So 1 radian is the same as the arc length. So you see that we've got 2 radians noted and so on. I think the easiest way to think about radians is that you're breaking up the circumference of a circle, which would be a full rotation. So the circumference of a circle is defined by 2 pi r. 2 times pi times the radius of that circle. Well, if we're going to relate arc length to an angle measure, how far we've rotated, then we're going to break it up in terms of 2 pi r. A lot of the things that we're going to be doing in this class live on what we call the unit circle. The unit circle is just a circle with radius is equal to 1. So on that unit circle, the circumference, the arc length, or the path all the way around that circle has a length of 2 pi. Now we can talk about traveling all the way around the circle. When we talk about rotations, we start at the positive x-axis. For positive values, we're going to travel counterclockwise. So if I travel counterclockwise all the way around the circle, I say that I have traveled, so theta is an angle measure, so I have traveled 2 pi radians. On the unit circle, this is also the circumference. So you can see how that circumference, or the length around, is equal to the angle traveled. So now let's go ahead and break this up. Let's say instead I travel halfway around that circle. So if I travel halfway around that circle, I've gone half of the circumference. So the angle measure that I've traveled here is going to be pi radians. So here, half, theta is equal to pi radians. Now I'm writing out radians, but if that unit is ever left off, it's implied to be radians. I'll put that in parentheses there. Okay, so radians relates directly to the length of the circle that we've traveled, or the arc length. Well, let's just keep going. So if I travel a quarter of the way around my circle, so if I land here, let's see, if I do it in terms of pi, I'm at half of pi. So here, theta is equal to pi divided by 2. So that would be this rotation. I can also travel negative, and that's going to be in the clockwise direction. So again, starting with, let me grab a different color. So starting with the positive x-axis, I'm going to go ahead and rotate in the negative direction a quarter of that circle. So theta is the length of that rotation. If we do this in radians, theta, I've traveled negative, because I've gone backwards in terms of these rotations, is equal to negative pi halves. Now I can also relate these to degrees. I can go ahead and put my degree measure on here in black. So I'll put this in black. So in degrees, a full rotation is 360 degrees. So theta for a full rotation is 360 degrees. So if I line these guys up, 2 pi radians is the same as 360 degrees. That unit is important, that little superscript circle that denotes degrees, because this gives me the difference between whether I'm in degrees or in radians where it's left off. Okay, now let's travel around half of that circle. Around half of that circle, that puts me at 180 degrees. A quarter of the way around the circle gives me 90 degrees. And if I move in the negative direction, a quarter of the way around that circle, I would also use a negative here, and that's going to be negative 90 degrees. If I go down to the next one, so just moving down a little bit, it's given us a lot of those different rotations. You see that first one there is pi sixths, or 1/6 pi. Let me write this out. I like to write it as pi sixths, which is the same as 30 degrees. So we've got a bunch of the common angle measures here labeled. So they've given us a conversion factor, and that's the one that we started with, that says 2 pi radians, so full rotation, is equal to 360 degrees. Instead, I like to use the fact that pi radians is equal to 180 degrees, just slightly smaller numbers. So we're going to use this as our conversion factor. So this is going to help us convert between radians and degrees. So for example, if I wanted to convert that pi sixths, it's in radians right now. I want to get it in degrees. So I'm going to multiply it using my conversion factor that I've got right here. So I want to multiply it so that I end up with degrees when I'm done. So I'm going to go ahead and put the 180 in the numerator, 180 degrees, and pi in the denominator. This is going to let me cancel. These are actually radians. So this lets me cancel the unit radians along with the pi. And I end up with 180 over 6. And 180 over 6 is 30 degrees. So we're going to be doing these conversions using the fact that pi radians, that half of a rotation, is the same as 180 degrees. So here we've got some rotations. So this is a good summary of what we've seen. Let's go ahead and put in these values. So here I haven't traveled at all. So I'm just sitting there on the positive x-axis. In degrees, this is 0 degrees. In radians, it's 0 radians. Now we've traveled from the positive x-axis a quarter of the way around the circle. In degrees, this is 90, but pi halves in radians. Again, from the positive x-axis, I'm traveling now half the way around the circle, so it's 180 degrees, or pi radians. Now I'm traveling 3/4 of the way around that circle. So this is another 90. So 180 plus another 90 gives me 270 degrees. This one is also known as 3 pi halves. And then finally, this is a full rotation. So that full rotation all the way around in degrees is 360 degrees. All the way around in terms of radians equals the circumference of the unit circle anyway. And so that's going to be 2 pi. Okay, so radians versus degrees. We want to go ahead and do some conversions for things other than these common, we call these quadrantial angles. Let me write that down. Quadrantial angles, because they land on one of our axes. They land on one of the boundaries between our quadrants. Down here, we've got a few quadrantial angles, but for the most part, we've got angles that are not on one of those boundaries, one of the axes. We're going to go ahead and start with the conversion factor. So that conversion factor is that 180 degrees is equal to pi radians. So this gives me my unit conversion. I can either multiply by 180 over pi, or I can multiply by pi over 180. If I multiply this first one, I'm going to end up in degrees. If I multiply by the second one, I'm going to end up in radians. Okay, let's go ahead and do 45 degrees. For 45 degrees, I'm always starting at the positive x-axis. If I travel 45 degrees, then I've traveled here. This is 45 degrees. To find that in radians, I'm going to go ahead and take 45 degrees, and I'm going to multiply it by the conversion factor I want to end in radians. So I'm going to multiply it by this one, pi over 180. So I end up with 45 divided by 180, and you can go ahead and do this in your calculator. I'm going to show you how to get your calculator to do the fractions for you even, because it is so nice. So we're going to do 45 divided by 180. If I hit enter, I end up with 0.25. I know that's 1/4, but just so that you've got the conversion to a fraction on your calculator, you're going to go to math and then choose that first option. So I'm going to hit enter to choose convert to fraction, and it gives it to me as 1/4. I can also, I'm going to arrow up here, and I'm going to grab that 45 divided by 180, and I'm going to do my conversion right here. Convert to fraction even before I hit enter, and it will return 1/4 for me. So this gives me then 1/4 pi, or pi fourths radians. So pi fourths. I also have, let me minimize this guy. I also have a blank unit circle over here that has a lot of these common angles marked out. I want to go ahead and mark this on my blank unit circle, and that's going to be this one right here. So this guy right here is 45 degrees, or pi fourths. What I'm doing, if I go ahead and go back to my worksheet, what I'm doing is I'm actually working to get all of the angle measures that we've got up here. So you actually already have them labeled. Let's go on to the next one. So the next one is pi thirds. So for pi thirds, I want to convert this one into degrees. So I'm going to take pi thirds and I'm going to multiply by my conversion factor, but I want degrees when I'm done. So I put 180 in my numerator and pi radians in my denominator. I can cancel pi. I get 180 over 3. I can do that in my head, and I get 60 degrees. So 60 degrees. On your unit circle here, that rotation gets you to this one right here, 1/3 of the way to pi. So this is going to be 60 degrees, or pi thirds. I want to show you one other way to do this. Let me grab a different color pen here. I'll do it in yellow. The other way to do this is to take that pi thirds and just replace pi with 180. I've got that nice equivalent. So I get 180 divided by 3, which gets me right to that 60 degrees. Let's go ahead and try that trick with part D. So now I've got pi sixths. So I have pi sixths. I'm going to just replace pi with 180 degrees over 6, and I end up with 30 degrees. On that unit circle, that's going to be this rotation right here. So this one is 30 degrees, or pi sixths. Okay, continuing to work my way through these. Now I've got negative 5 pi sixths. I can do the very same thing that we did before by replacing that pi with 180. So I have negative 5 pi, so I'm going to change that to 180 divided by 6. Let's go ahead and just put this one right into the calculator, because why not? So I get negative, okay, great, 5 times 180 divided by 6. I can convert to fraction, but I know it's going to turn out to be nice. This one's negative 150 degrees. So let's just get rid of that guy. So negative 150 degrees. This one is traveling counterclockwise. So as I'm traveling counterclockwise, let me grab a different color pen here. So if I'm traveling counterclockwise, 150 degrees, I'm not quite to 180 degrees. I'm 30 degrees shy. So I'm traveling from the positive x-axis, but I'm traveling to here. So this guy right here, moving in the negative direction, is negative 150 degrees, or negative 5 pi sixths. Notice if I kept traveling all the way to the halfway point, that would be another pi sixth. So that would be negative 6 pi sixths. Grab my pen again. So that would be negative 6 pi sixths, also known as negative pi. So I can count these out in terms of pi sixths. Okay, 90 degrees. This is a really nice one, right? We know that 90 degrees is the same as pi halves. I can do my conversion though. I can do 90 degrees times pi over 180. I go ahead and cancel, and I end up with pi divided by 2, so pi halves. 270. So 270. I want radians when I'm done, so pi goes in the numerator, 180 degrees goes in the denominator. We can let the calculator again do this calculation. So I'm going to go 270 divided by 180, and I want to convert this to a fraction. So I'm going to go math, convert to fraction, and I end up with 3 halves, and I've got that pi as the multiplier out in front. So I have 3 pi halves, 3 pi halves. In terms of my unit circle, let me grab my blue pen again. I want to show you how to start using radians. They're really nice for counting increments. They're actually nicer than using degrees for counting increments. So if I travel 1 pi halves, I land here. So this is pi halves. If I travel here, I'm at 2 pi halves, which is also equal to pi. If I travel here, I've gone 3 of those pi halves. So 3 pi halves or 270 degrees. I can do the same thing if I'm counting out. Let's do the pi thirds. Grab a different color. I'll do these in yellow. Okay, so we've got one of the pi thirds here. So I've got pi thirds. If I travel another, that would be another 60 degrees. I end up here. Let me grab that again. I lost my pen. There we go. So if I travel another 60 degrees, I land here. I'm counting out pi thirds though, so this is going to be at 2 pi thirds. I travel another 60, I'm here. This is 3 pi thirds, or pi. We just continue going around. Another 60 puts me here. This is going to be 4 pi thirds. And then 5 pi thirds. And then the final 60 degree puts me at 6 pi thirds, or 2 pi. So it's a really, really nice way of breaking this up. You can think of this as pieces of a pie. So I've got a piece of the pie here, another piece of the pie, another piece of the pie, and I've just counted these pieces out all the way around my circle until I have 6 of those pieces. So dividing that into sixths. We can do the same thing with pi sixths. We can do the same thing with pi fourths. So a really nice way to work your way around that unit circle. Okay, back to our worksheet. What are we on now? H. So I've got 210 degrees. I'm going to start using my unit circle to get to these answers. I can just convert it, but it's really nice if you base everything off of your halfway points and your entire full rotation point. So this is 180 degrees, halfway around, also known as pi. This is 360 all the way around, also known as 2 pi. Well, 210 is 180 plus 30 degrees. So it's going to land me here. So I know that 180 is pi. 30 degrees is pi sixths. So I must be, because this guy would be 6 pi sixths. I know I'm making it seem confusing, but trust me, you're going to want this level of understanding when you're doing the trig to make things so much easier. So I'm 1 pi sixth beyond the halfway point. So that puts me at 7 pi sixths. Let's go ahead and count them out around our unit circle. I'm going to use a different color here. I'll use red. Okay, so as I'm going around my unit circle, these are going to be in chunks of pi sixths. Get my pen back. There we go. Okay, so chunks of pi sixths. This right here, that rotation, this is pi sixths. This guy right here would be 2 of them, so 2 pi sixths, also equivalent to 5 thirds, right? So another one, this one is 3 pi sixths, equivalent to pi halves. I go another 30 degrees. This one is 4 pi sixths, which is the same as 2 pi thirds. Here must be 5 pi sixths. Halfway around is 6 pi sixths. Perfect, that's pi. And then if I go another 30 degrees, I end up at 7 pi sixths. I can keep going with these. So I've got 7 pi sixths, Another 30 degrees gets me at 8 pi sixths, which is 4 pi thirds. Another one gets me at 9 pi sixths, which is 3 pi halves. And then this is going to be 10 pi sixths, also 5 pi thirds. This is 11 pi sixths. And then the last one had better be 12 pi sixths, getting me all the way around. And it does to 2 pi. So I count these out in chunks, like pieces of a pie. Okay, let's keep on going. So negative 135 degrees in radians. I'm going to go back and I'm going to do this one using our conversion. Whoops, it's 135 degrees, not 130. So 135. I want to get rid of degrees. I want radians. And I'm going to go ahead and just put that right into my calculator and do a convert to fraction. So I'm going to do negative 135 divided by 180. And I want to convert to fraction. So math, convert to fraction, enter, and I get 3/4. So I'm at negative 3 pi fourths. So this is negative 3/4 pi, or negative 3 pi fourths. Okay, negative pi halves. Pi halves, I know that pi halves is 90 degrees. So 180, just replacing that pi, is going to give me negative 90 degrees. Okay, and then finally, 5 pi. So I'm going to do 5 pi. 5 pi is 5 times 180 degrees, getting that into degrees. So I'm just going to go ahead and multiply 5 times 180. And that is 900 degrees, equals 900 degrees. If I were to do this rotation out, I'm going, this would be 1 pi, 2 pi, 3 pi, 4 pi, and finally 5 pi. So 5 pi turned out to be 900 degrees, but I also ended up with these coterminal angles. I kept landing on the same place, although for a lot of applications, thinking about the orbit maybe of a satellite, how far around it went to get there is really important. But we do have these coterminal angles. 5 pi lands on the same place that 3 pi and pi do. And we also saw that these two are coterminal angles, 4 pi and 2 pi. There are infinitely many coterminal angles. Let's go ahead and come up with some coterminal angles for number 3 here. So we want some coterminal angles for 420 degrees. Well, I know that 420 degrees is past 360. So if I go ahead and subtract 360 degrees, I take a full rotation out, I end up with, 60 degrees. So 420, you draw it right here. So 420 gets me all the way around plus 60 more. So this is 420 degrees, which makes it coterminal with just traveling 60 degrees. So I can write that as coterminal to 60 degrees. I can also, what's important now is where I'm landing. So I'm landing right here. I can also get there maybe, say, with an extra rotation. So what if I travel to 420 and then I travel another 60 degrees? So I can go ahead and take 420 and add another 360 full rotation. That's going to give me 780 degrees. So there's another one, 780. I could also subtract 2 rotations, right? I'm just adding and subtracting multiple rotations to get to where I want to go. So if I wanted to, I could also go ahead and work backwards. So I could take that 420 and I could subtract out 2 full rotations. So another way to do it would be 420 minus 2 full rotations. You can add and subtract as many rotations as you want to come up with a coterminal angle. So to come up with these coterminal angles, I'm just adding and subtracting. Whoops, I don't want that. Adding and subtracting rotations. Let me move this over so we can see everything. And then I want to do 420 minus 2 rotations. So I'm going to do, let's go back here. So I'm going to do 420 minus 2 rotations. So 2 times 360. Infinitely many options here. So there's another one at negative 300 degrees. So negative 300. do this in black. And those are degrees. Now let's do it with pi fourths. So negative pi fourths lands me right here. So this is negative pi fourths. I'm going to do the same thing. I just want to add and subtract rotations. First of all, I can use my unit circle without even having to do some math here. If I travel in the positive direction, I can come up with another coterminal angle. Let's see, this is 0 or 2 pi. In terms of fourths, this would be 8 pi fourths. I don't want to travel 8 pi fourths. I want to be just one short of that. So that would travel me 7 pi fourths. That gets me to one of my coterminal angles, 7 pi fourths. From there, I can just keep adding and subtracting full rotations. But for these, I want to add and subtract 2 pi. So let's go ahead and take that negative pi fourths and let's subtract a 2 pi. So I want to go backwards another full rotation to land on another coterminal angle. In my calculator, I'm going to ignore the pi, and I'm just going to do negative 1/4 minus 2, and then I'm going to put the pi on when I'm done. So making this as simple as possible for my calculator, I'm going to go ahead and take negative 1/4, so negative 1/4 minus 2, and I know I want this expressed as a fraction, so I go math, convert to fraction, and I get negative 9 pi fourths. So negative 9 pi fourths is another one. That came from this guy. And then let's go ahead and just do another one. We subtracted 2 pi. Let's subtract 4 pi this time. So another one would be negative pi fourths minus 4 pi minus 2 rotations. There are infinitely many answers to these. So this time we're going to do, I just want the negative 1/4. So I'm ignoring the pi for now. So negative 1/4 minus 4. And I know I want to convert that to fractions. So math convert to fraction. And this gives me 17 fourths. And I know that I've got a pi in there. So 17 fourths is negative 17 fourths pi. Okay, infinitely many of these coterminal angles. We're just adding and subtracting full rotations. And a full rotation in degrees is a multiple of 360. A full rotation in radians is a multiple of 2 pi. So that takes us through our angle measures. There's a lot of things to practice here. You're going to get a good handle on the unit circle, which I've made a mess of here, but getting more and more comfortable with where these radian measures are and where the degree measures are around this unit circle is going to be key to being successful as we move through trigonometry.